This is a projectile question, an example question let's look into. You are preparing breakfast and slide a plate on the countertop. Unfortunately, you slide it too fast and it flies off the end of the countertop. The first information is not needed for solving this equation, this question. It flies off the end of the countertop. This is where our problem starts. The countertop is 1.05 meters above the ground floor, and the plate leaves the top at these many meters per second. How long does it take it to fall, and how far from the end of the counter does it land? Now, as I always suggest, first you just sketch the diagram and try to label the quantities if there are distances or heights given on the diagram so that you don't make mistakes in swapping these quantities as vertical or horizontal. So the plate is sliding off from the countertop and it is hitting the floor, right? And what are the information given to you in the question? 1.50 meters above the floor. So the height of the countertop, so this vertical height is 1.05 meters above, and the plate leaves the top at 0.75 meters per second. So which velocity is this? It is the horizontal velocity, right? V horizontal is 0.75 meters per second. So those two are the quantities given in the question. Let's approach the question as you're all expected to solve. So first you put horizontal and vertical. So enter all the values that you know of in each of these columns. So the first one, vertical speed, is known to you. So I put that here. It is 0.75 meters per seconds. And vertical height, here I have the displacement or vertical height, that is 1.05 meters. Since it's perfect horizontal line, you're just pushing it sideways, the start speed of this would be 0 meters per second. And also, we know that it's free fall. We are ignoring air resistance, so the acceleration should be negative 9.8 meters per second square. So once you put all these values in, then you can look into what is asked and whether you could use the quantities on vertical or horizontal to solve. As I have always told in class, here there are three quantities involved. So if you know any of the two, the third quantity could be found. But here I know only one velocity. I do not know the time. I do not know the distance. So it's impossible for me to solve any of these at the moment. So let me look at the quantities that are on the vertical. Now here by the side, you can use the simplified version of any of the equations. Vf is Vi plus At. Then we have x equals Vit plus half At square, and Vf square equals Vi square plus 2ax. Notice I'm not written xf minus x0. This also I've simplified. So you've got these three equations. You can use any of that to solve for this question. Now I would find the time by using the vertical quantities as I said before. So which one would be the easiest one? It is this one. If you know the height for the vertical or the horizontal perfect projection, it's always advisable to choose this equation because the time will get simplified too. This VIT will entirely get vanished because VI is 0, right? So one complete expression gets eliminated. So you would be left with x equals half AT squared. So all you need to know is the vertical height. You can immediately find the time taken. So I repeat, perfect horizontal projection, all you need to know the vertical height to find the time. So when you change the subject of the formula, t would be 2 times x, it will go to the numerator. So 2 times x upon a, and then you have that as square root. So you substitute those values here. Displacement, it's coming down, you have to take that as negative. So you put all the values, you will get the answer. It is 2 times x height is 1.05 0.05 divided by 9.8 equals, and square root of the answer, you should be getting 0.46 seconds. So 0.46 seconds it takes for it to land on the ground. This is simplest projectile question. Perfect horizontal projection. If you know the height, you can immediately find the time by using this equation. Keep this in mind so that you can save time. And there's one more part of this question. How far from the end of the counter does it land? And as per projectile concept, we know that the time can be used in both because it takes the same time. Vertical acceleration is the same. Horizontal acceleration is 0. So I can use the time here also to be 0.46 seconds. So I've got velocity and time from the end of the counter. So this is horizontal displacement. This is the second part of the question. So this distance is asked. So we use the formula speed is equal to distance over time, or distance is speed times time. So you have 0.75 times 0.46, which is roughly about 0.347 meters. So here we have found the time and we have also found the horizontal displacement. So the approach to the question for solving any perfect horizontal projection would be the same. So follow this rule, split it into horizontal, vertical, plug in all the values that are given in the question, we'll be able to choose the appropriate formula.